Welcome to Tejas Statistics. Now, in this class, we are going to discuss about the control charts for attributes. First of all, we are going to see about the P chart. So, an error is a any place of a product is known as defect. So, defect it indicates a lack of quality of the product. An item consisting of at least one defect is known as a defective product. Let us consider a population of manufacturing of a product in which the quality of the product is measurable by introducing an attribute called defective. So it is saying they are saying that it is a defective item, whether it may be the having the two chances. One is having the problem or error, or it may don't have the problem or error that product. So these two are said to be the attributes. Okay, so let us consider a population of manufacturing of a product in which the quality of the product is measurable by introducing an attribute that is defective. Every product have two chances, either defective or it is a non-defective. Very good. Next, coming to select a sample of size of n from the population in which x are the number of defective products. By the definition of the binomial distribution, x follows the binomial of n comma p. So this is a capital P. You can variance of xi is npq. The capitals you can write. Okay, let small p is the fraction defective. What is fraction defective? Here is number of defective products out of the sample size x, that is x divided by n. So expected value is called the proportion. So here expected value of that p, first of all we are doing the proportionality. Expected value of x divided by n, that is equals to 1 by n, and expected value of x. What is expected value of x? So here the x follows the binomial distribution, hence we can take the n into capital P. So n gets cancelled, it will be the capital B. Next, coming to the variance of the proportionality, p is equals to variance of x divided by n, that is n variance that it can be written as 1 by n square, and variance of x, that is 1 divided by n square of variance of x value, because x follows the binomial. So this is npq value. So n into p into q, you can put it in the capitals also. So n gets cancelled and pq divided by n. Here the standard deviation of that p is called that is under root of pq divided by n. So for this the 3 sigma limits, you can see the upper control limit UCL value is equals to expected value of p plus 3 into standard deviation of p. So capital P plus 3 into under root of pq divided by n. The 3 divided by root n can be written as a, p plus under root of pq, that is a into pq under root of pq. That is our UCL, and LCL will become p minus a into under root of pq. What is our CS? Central line or control limit, that is p. From the above central limits or construct a p chart by taking the sample numbers on x-axis and the quality on y-axis. Construct the quality, that is a chart. Sample numbers on x-axis and the quality on y-axis. If all the sample points are lies between UCL and LCL, then the production process is said to be under control. Otherwise, it is said to be out of control. Okay, this is about the P chart. Next, go with the NP chart. What is our NP chart? NP chart, here it is the number of fraction defective chart. Number of fraction defective chart. Yes, an error in a place of a product is known as a defect. It indicates a lack of quality of the product. An item consisting at least one defective, then it is known as defective product. Let us consider a population of manufacturing products in which the quality of the product is measurable by introducing an attribute defective. Every product we have the two chances, either it may be the defective or non-defective. Select a sample of size n and product from the population which d are the number of defective products. So here directly we are considering the defective products. By the definition of the binomial distribution, we have d follows the binomial distribution with the expected value of d is equals to np and variance of d is equals to npq. The control charts directly we can consider the ucl and the lcl. By the 3 sigma limits, the d control limits are given by the 3 sigma limits wh watt, that is the UCL is equals to expected value of d plus 3 into the standard deviation of d, that is np into 3 into under root of npq. So defective products, number of defective products. LCL np minus 3 into under root of npq, and cl is np. So here in case 1, if p is known, then you can put it as directly in the solution. Case 2, if p is unknown, then it is not given. Consider for that the population is divided, the total population is divided into k groups with the equal sizes, and d1 d2 d and dk are the number of defectives. So you have to consider the d bar. So summation di divided by k. So d bar, expected value of d bar is equals to summation di divided by k, and that is summation will be over there, that is expected value of di is equals to n into p. So n gets cancelled, that is k into np, sorry. So k gets cancelled, that is n into p. So expected value of d bar is equals to d bar divided by n. For the p value you can estimate d bar divided by n is an unbiased estimator to p. So the 3 sigma control limits will become n into d bar divided by n gets cancelled, d bar plus 3 into under root of d bar into 1 minus d bar divided by n. Very important. And LCL and CL also you can see. After that you can construct the D chart. From the above control limits, construct NP chart or the D chart by taking the sample numbers on x-axis and the quality on y-axis. If all the sample points are lies between this UCL and LCL, then the production process is said to be under control. Otherwise it is said to be the out of control. The next chart is the C chart. What is an C chart? The control charts for attributes. In that we are learning the C chart. So here let us consider a population of manufacturing a product in which the quality of the product is measurable by introducing an attribute. It is a defect. In the given population of the product, every place of a product it is having the two chances, either the defective or non-defective. Generally the number of defects are more than number of defective products. So we can use the Poisson distribution, which is bigger than the binomial. Let us see be the number of defects in the given sample of the products. So C follows the Poisson distribution with the parameter lambda. Therefore the control limits are given by, so expected value of C is equals to lambda, variance of C is also be the lambda, standard deviation of C is equals to under root of lambda. Therefore the 3 sigma control limits are expected value of C plus 3 into standard deviation of C, that is lambda plus 3 into under root of lambda, and LCL lambda minus 3 into under root of lambda, CL is lambda. In case 1, if if lambda is known, UCL, LCL and CL, directly you can put that values. If case 2, if lambda is unknown, then consider the total population is divided into k groups with the equal sizes, and C1, C2, Ck are the number of defects. So Kk gets cancelled, and the expected value of Ci will be the lambda. Okay, C bar. Okay, so C bar is an unbiased estimator to the lambda. So C bar plus 3 into under root of C bar, so C bar minus 3 into under root of C bar, and CL is equals to C bar. From the above control limits, construct the C chart by taking the sample numbers on x-axis and the quality on y-axis. Then you will get the graph. If all the sample points are lies between the UCL and LCL, then the production process is said to be under control, otherwise it is said to be out of control. This is about the C chart. And last but not least, the U chart. In this chart, instead of plotting the statistic U, okay, plotted where UI is equals to Ci divided by Ni, where Ni is the sample size and C is the number of defects per far different sample sizes. In that before that is a fixed sample size, it is different. Okay, let the population of the capital N is divided into k groups with the unequal sizes n1, n2 and so on nk, and in which C1, C2, Ck are the number of defects per unit. Okay, per unit. And corresponding samples UI is equals to Ci divided by Ni. Expected value of UI is equals to U bar, and variance of U is equals to UR divided by N. So standard deviation is under root of U bar divided by N. Therefore the control limits are the 3 sigma control limits are UCL is equals to U bar plus 3 into under root of U bar divided by N. So 3 divided by root n brings you the A, capital A value, that is under U bar plus A into under root of U bar, that is LCL U bar minus A into under root of U bar, and CL is U bar. Construct U chart by considering the sample number on x-axis and the quality on y-axis. Okay, if all the sample points lies between then UCL and LCL, then the production process is said to be under control, otherwise it is said to be the out of control. With this we are going to complete our complete chapter on the SQC. Okay, for the final years this is a very important unit. Okay, unit number 4 in the new syllabus. Thanks for watching Tejas Statistics.